In this video, we are going to talking about the shadows. In the previous version of the Three.js, we don't have shadows. However, in the earlier version, we have a different section called shadows, referred to the shadows settings. And in today's video, we are going to talk about the light shadows, and we need to actually satisfy this requirement in order to show the shadows in our environment. As you can see here, we actually created a renderer using WebGL renderer, and after that we enable shadow map and set the shadow map value to the true, and actually write the type of the shadow map. As you can see here, if you are not actually define this shadow map type, and the default value is PCF shadow map. And as you can see here, in today's video, we are going to actually work on the shadows in this line of code. I just wrote the code refer to the creating WebGL renderer, and I initialize the constructor. And as you can see here, the default value is like that, but if you're initializing your code like me, it will be more smoother. And as you can see here, the processing actually will be heavier than the default values. So anyway, in the next lines, I just wrote the shadow map enables. I satisfy that, and I make it true, and I just create a geometric box added to the our environment, and I just create a plane, the lights, and afterward I just going to specify the settings about the shadows. In the WebGL, we just said that we are going to have a shadow in our renderer. If we just remove that part, you can see that we don't have a shadow anymore. And afterward, we need to actually specify some settings on our object. First of all, this is our cube, and as you can see here, there is a point light here, which actually I specify to the light that I want to cast shadow by the light. So I just wrote it light.cast shadow equal to true, and after that I add it just to the scene, and let's see if what happened if we don't have it. As you can see, we are not going to have the shadow. And also I set to the cube geometry box that we want to the shadow casted from that box. So the light going to the cast shadow, and the cube is cast shadow also set it to true. However, in plain, we are going to actually set the receive shadow to the true in order that to actually able to show the shadow of the cube on the plane. And every object, every geometric, every mesh in environment, in order to show the shadows, have two specific shadows, which we need to define it to one of these. As you can see here, as you can see, we actually can specify the width and the height of these map size. We said that the map size is a matrix that we are going to change these values and make it smoother. And from so on, we see that we have settings related to the shadow, and there is a direct like that I wrote it before, and I just make it code. And as you can see here, I write a directional right. I just remove these parts, and I just make the cast shadow equal to true. So at this moment we have two lights. One of them is point light and one of them direct light. In the nature of the light and the shadow, if two lights actually casting on an object, the representing shadow will actually union from those shadows. So as you can see that these parts will going to remove from our shadows. And if I just remove the direct light, as you can see, direct light points from the top to the bottom in the x-axis. And as you can see here, the union of these shadows will be shown up in our plane. And as a matter of the fact, because the directional light casts the light from the y-axis to the cube and to the plane, and we have a point light from the somewhere in our environment, the shadow will be union of these casting lights. And as a matter of the fact, if I change the directional light x-axis values, the combination of these shadows will be changed. As a matter of the fact, you see that we have two different type of shadows, and they have a different textures. As a matter of the fact, because one of them is 1024 and the other one 2048, and I just reduce it to 128 to reduce the graphics processing power. And as a matter of the fact, you can see the difference right now. It's like pixelize the shadows. So you can see that it's easily actually we can define these shadows, this light. So we will actually revert the changes that we done it before. So now we are going to cover this part, and I just set the X positions to the 10, and this is our environment. And as you can see, we have two different lights and shadows. So, and what are these supposed to mean? When you are creating a metaverse or a game, every object has a relations with their camera, and every shadow has the relation with their object geometry. So by considering this fact, we can say that each object have a specific shadow related to their light. When a player in the game or in the metaverse moves on this environment that you are creating, and every object has the zone, has the ratio, that until that ratio they will actually render, the game will render their shadows. And by specifying this fact, we can actually consider that the processing power will be reduced. And one point is that when you're zooming and zoom out, the position of the camera is not changing corresponding. However, if we want to see these changes, we can actually apply different camera positions, and we can apply different different shadow camera values. For example, we have left, right, top, bottom, near, and far. And these values actually are based on the initial values of the camera. And if I found my camera positions, and let me see the camera, let me actually search it. Yes, we initialize the z-index position of the camera is 15, and let me check, and I just remove this part. Okay. As you can see here, our camera initial positions is changed. And after that, if we change the far attribute to the 15, we can also see the shadows, the grayer shadow on the below of the cube. If we actually make it more, it means that the value will still be represented in our environment. But if we specify a less value, as you can see, the shadow will be vanished, and the player cannot see all the shadows related to that light. Remember that we have two lighting system in here: point light and directional light. And if I just want to show you to in the mondial3d.com, there is a metaverse builder here. Here you are. There's a person here. We just create a cube, just add the cube, and as a matter of the fact, the character will explore on the environment, and the position of the camera will change. So if you goes on that area that we set it in our code, that we are going to have the shadow enabled, we have the shadow. So from this far, the character doesn't need to actually see the shadow. And this feature will reduce the processing power that GPU, that hardware done each time of the iteration that users move and explore in the environment.